Welcome to RCR Wireless News. I'm Martha DeGrasse, and this is the Carrier IoT Case Studies webinar. I'd like to introduce you to your panelists for today. Mobeen Khan is an IoT strategy and product executive at AT&T. Mobeen, thank you so much for being here today.
Thank you. Thank you for the invite.
James Brehm is our analyst today. He is founder of James Brehm and Associates. James, thanks for joining the webinar.
You got it. Thanks for inviting me.
Our sponsors today are Sequans and Sigfox. Craig Miller is Vice President for Worldwide Marketing at Sequans. Craig, thank you very much for being here. It's great to have you back.
Thanks, Martha. Glad to be here.
And Michael Orr is Vice President for Sales and Partners for North America for Sigfox. Michael, thanks for being here today.
It's a pleasure to be here today. Thank you for having me.
And I'm Martha DeGrasse with RCR Wireless News. A quick word about RCR Wireless News. We are a premier news source for the wireless communications industry and a leading provider of carrier, network, device, test and measurement, telecom software, and IoT news. Find us at rcrwireless.com, at our newest website, enterpriseiotinsights.com, and find us on YouTube, where we have more than 6,000 videos. I'd also like to call your attention to a report that published today outlining some IoT case studies. We have two case studies from AT&T, one involving connected water meters and one involving a smart cities pilot project. We have a Verizon case study detailing smart agriculture, a Vodafone case study detailing connected medicine vials to prevent medical waste, and a Sigfox case study, detailing connected oxygen tanks. And you can download this report at our website. Now, at this time, to begin our discussion, we're going to go to James Brehm with James Brehm and Associates.
Thanks,
James,
Martha.
Thank you.
So, we are James Brehm and Associates is a consulting and market intelligence firm. Foundation of what we do is numbers. We provide project-based and retained strategic advisory services based on the deep knowledge and the numbers that we capture in the space. If we can slide to the next slide. So when I thought about this webinar, the first thing that came to my mind is that people that are looking to deploy solutions, people that are coming to the webinar for knowledge, what decisions need to be made? What goes through the chief IoT executive's mind when he's making the decision what to do? And it's what hardware do we select, and is it going to be secure? What cloud service provider do I have to use? What KPIs? How do I handle change management of the products in the future? I mean, there's so many different decisions that need to be made, but the number one thing that you need to take a look at, in our opinion, based on the research that we've done as an organization, and you'll see that on the next slide, Martha, is you really need to weigh the cost of taking action against the risk of doing nothing and figure out, are you ready to do this? And then get management buy-in. That's the key. Board level management buy-in on what you're doing. Start with a specific business area, keep management engaged and up to date with all the decisions that you're making. Determine what that business objective is. Are we doing it for compliance purposes? Is it just a simple pet project improving efficiency? Or are we going all the way through and transforming our business? So there's so many different things that you can do with IoT. We're seeing companies transform their entire businesses. Well, are you ready for that? But make certain your goals align with management goals, and make sure that you actually have a measurable ROI at the end of the day. So remember that it's gain minus cost over cost is the easiest way to determine that metric. But what's the cost of not buying, not getting buy-in? It's failure.
Excellent.
If you don't have management buy-in, it's failure.
Thank you very much, James. Next, we're going to hear from Mobeen Khan with AT&T.
Hi, good afternoon. This is Mobeen Khan. I'm sure a lot of you are familiar with AT&T investments and products in IoT. I'll just sort of recap at a very high level some of the areas that we are focusing on from a customer perspective, and then from a product perspective, and then we'll go into the case studies at a later time. There are over 30 million devices, IoT devices now connected on the AT&T network, and it's growing at a very, very nice clip every quarter. A significant number of those are cars and other types of vehicles. So cars as in consumers, you and I buy a car which is wholesale connected to OEMs who run diagnostics on the engines and the brakes and tell you to go get your oil changed. But also with Wi-Fi hotspot in the car for the family to connect to that hotspot for with their tablets or cell phones. In the future, we're looking to bring in other products like entertainment and so on in the car. On the enterprise side, a lot of fleet vehicles, fleet solutions, asset management solutions for what's in the back of the truck, if you will, and solutions around driver behavior. So think of insurance products and figuring out whether you and I are good drivers or not. Other areas of focus have been in the smart cities, which includes meters and water meters and electrical meters, grid. There'll be we'll discuss that later this afternoon. And then going into let's call that a developer and SI experience with platforms, where we are bringing in a lot of small and large systems integrators and enterprise developers to help them build IoT solutions from scratch. A lot of focus on innovation with a concept that we call Foundry. There's foundries focused on IoT, where we do co-innovation with partners and customers. As some of them are vertically focused, like on the car in Atlanta, healthcare in Houston, and then general IoT foundry in Dallas area. So that's sort of a high level I wanted to talk about. In terms of the, what is AT&T doing in terms of product sets in the area? We think of our products are more as more horizontal products, but we go to market in a fairly verticalized way. So the horizontal products obviously start at the cornerstone is our network. The LTE network, and if you've seen the announcements, we'll be pretty soon launching the nationwide LTE-M network. So this is allowing low cost, long battery life, highly penetrable connectivity into anything and everything, primarily focused on rather lower speed connectivity. So think about, again, I'll use meters as an example where you need 10-year battery life, perhaps, or elevators where you need deeper in-building through the walls of concrete connectivity. So that's sort of network. Platforms, we have two products in the market called Flow and M2X. You can try them out as a developer today on our developer sites. And allows you to collect data from all kinds of IoT devices very quickly so that you can start to build applications and solutions. And then obviously we offer at the back security and sort of cloud enablement to things like AWS and Azure. So that's sort of our horizontal product set. And from a verticals perspective, we are engaging with our customers. We have a sales team that engages with them on a vertical by vertical basis.
All right.
Slide.
The next slide is Craig with Sequans.
Okay.
Thank you, Martha. And thanks everyone for joining the webinar today. We're happy to sponsor this event. LTE for IoT is what we do, and so webinars like this are a good opportunity to both hear from and communicate to the audience in the IoT community. So thanks. I'm going to introduce just briefly, a minute or so here, what Sequans is all about, and then maybe a few minutes on some data or some information that hopefully you'll find useful. For those of you who don't know Sequans, we're an LTE chip maker, and kind of our mission right now, our priority is LTE for IoT devices. Our currently shipping LTE for IoT chipsets in our Streamlight LTE family are kind of shown here, and they include Monarch, which is the industry's first LTE-M chipset, also capable of supporting narrowband IoT. And we're also showing here that we have the full range of Category 1 and Category 4 chipsets that are optimized for IoT applications. And we think they're the most cost-effective and size and power optimized solutions for a wide variety of IoT use cases. And then just today, it's not on the slide, but just today we introduced Monarch SX, which is a highly integrated system-on-chip solution for the Internet of Things. And you can go on our website and find more information about what that's all about.
Well, that's great. Thanks for letting us know about that.
So why LTE for IoT? This is kind of where I want to share a little of our perspective on why you should care. There are other options, obviously, 2G, 3G, some of the unlicensed solutions that we'll hear about later today. Our position is, LTE has a lot of stuff going for it, and the first one is the industry itself, which is massive and innovative, based on a global standard, and has longevity, kind of a promise of a longevity on its side. And this is pretty important for a lot of IoT use cases if you care about the network being available for years to come. Second is the LTE networks themselves provide great coverage, great capacity, and this is all happening while legacy networks are shut down or approaching their sunset, and the unlicensed networks, candidly, still have to be built. So you've got networks out there already in place. And third is kind of the technology itself does provide for performance that a lot of IoT use cases do care about, including low latency, the throughput that some applications need. It's an all IP scalable networks, great mobility, support for VoLTE. There's a whole lot of technology attributes that are good for these kinds of applications. And then fourth, tip of the cap to the operators like AT&T on the call today. They bring great geographic coverage and reach with their networks. On managed access in licensed spectrum. They have proven robust security and authentication schemes, and frankly just a strong track record of reliability. So, and then finally the roadmap. I give ourselves some credit. Implementers like ourselves of 3GPP standard technology, I think we've done a great job with the roadmap, delivering quickly a range of innovative solutions that deliver the range of LTE categories for IoT across the diverse use cases that are out there. So you have specifications like LTE-M and narrowband IoT launching now. And so these solutions can offer years of battery life, better, deeper coverage, and modules that rival 2G in terms of price points. So lots of options available now. And then my last slide, Martha, is just an attempt to sort of depict this range of LTE solutions across the variety of IoT use cases that are out there. There's no one size fits all across the IoT landscape, so this diagram just shows how the various LTE flavors on the left over there, or categories as they're formally called, they map to different applications, ranging from very high bandwidth solutions at the top down to the tens or hundreds of kilobits down at the bottom. And there's an LTE-based solution for each of those. And the beauty is all of these categories can work on existing LTE networks in the same spectrum that's already widely deployed by mobile operators. So our position is there's kind of an LTE for IoT solution for almost any IoT use case. And Sequans is proud to have built highly optimized chipsets to provide solutions across this entire range.
Okay, great. Thanks. Yeah, this is a great slide. Thank you very much. Okay, at this time, we're going to hear from Michael Orr with Sigfox. Michael?
Hi there. I'm Michael Orr, Vice President of Sales and Partners for Sigfox North America. It's a pleasure to be here today, so thank you for joining. A lot of you out there may not be familiar with Sigfox, and I hope I can educate you today and enlighten you today on who we are and what we're all about. We at Sigfox see IoT as the next big industrial revolution. I've been in the mobile space for about 20 years, more than 20 years if I date myself, and pretty much that battle's won. Everybody has a phone, so maybe there's 7-8 billion devices out there active today. There are a lot more machines out there in the world, many times how many devices there are for phones, et cetera, in the world, so many times the number of humans. So with the combination of cheap silicon and cheap connectivity that's available today, virtually every device of the future will be connected. It doesn't take much money to put a chip in virtually anything, and then connectivity costs have come way down. So everything will be connected in the future. Surely within the next 5 years, every device that's built will be connected. Really, literally every device. So there'll be hundreds of billions of devices worldwide that are connected. So the real question then becomes, what do you do with all that capability? So there are many use cases for IoT. And remember, nobody buys IoT. Everybody buys a solution to a problem. They're trying to solve a problem. IoT is the way they get it done. To James Brehm's point earlier, ROI is key. You have to understand the problem you're trying to solve and the ROI for that problem. We see IoT as ubiquitous. It will just be part of everything. We see smart cities, smart homes, smart agriculture, smart hospitals. The possibilities are literally endless. Some of the near-term use cases that we see today are asset tracking. Once you can track something at a very low cost, lots of things will get tracked that aren't currently tracked today. Metering, water meters, et cetera, things like that. Predictive maintenance, or the ability to predict when you might need a new washing detergent load or something for your washer, things like that. And then regulatory compliance. Next slide, please. So how do you get to that picture of ubiquity? Sigfox is a global network dedicated strictly to IoT. That's all we do from the ground up, IoT. We're focused on mass IoT. What we see as being a missing part of today's IoT landscape. By that we mean low-cost items that individually have small amounts of data to convey, but in the aggregate have lots to say. So all these small data packages add up to big data. So small data becomes big data. For many devices, cost and battery life have kept them out of IoT. But envision cases of on, off, empty, full, occupied, not occupied, where am I in terms of location? Small amounts of data that virtually every device has a need to say. And so once again, the list is endless. We see three key pillars for a Sigfox-like network to be successful. It's got to be very cost effective. So both on the device side, meaning the silicon, and the device side itself, everything about that has to be very cost effective, and the connectivity has to be very cost effective as well. So not only does Sigfox have the lowest connectivity cost, we also have the lowest silicon cost and the lowest silicon size. It also, assuming that most of these devices are running on batteries, we have to have very low energy consumption. So Sigfox has transmission capability for the modem part of the device that we can enable 10 years of battery life for different devices. And of course, it scales easily through this cloud-to-cloud architecture. Very important. Next slide, please. And to echo something that Craig said earlier, there is no one way to connect for IoT. IoT is a vast space and requires many forms of connectivity. Local area networks on the one end offer local connectivity, as they say, Wi-Fi, Bluetooth, Zigbee, others. LTE and others, currently span the globe, have very wide areas of coverage. Sigfox addresses that vast area of devices that are currently not connected. You name it. It could be parking spaces, parking meters, utility meters, et cetera. The list is long. But it's completely complementary with existing technologies that are out there today. It's entirely possible, for example, that groups of devices might have multiple connectivity modes. For example, a Bluetooth module to communicate locally with your smartphone about the very same data that may use Sigfox to transfer data for long distances. And we have a use case we talk a little bit later about that very connectivity. So both battery powered, both using the same data, but slightly different applications. Again, the possibilities are endless. Next slide, please. So Sigfox is focused on and is present in 8 key verticals. Agriculture and environment, think of things like precision agriculture, crop sensors, livestock tags. Industry is quite wide ranging, but think of things like facilities management, inventory tracking within the factory environment, utilities, meter reporting, meter management, etc. Retail, that often turns into asset tracking, logistics, inventory management. Auto and fleet, think things like tracking, diagnostics, etc. Home and lifestyle, predictive maintenance, automatic replenishment. Public sector, smart cities, waste management. The list in the public sector is quite long. Health and assisted living, elderly security, for example. One use case we're working with currently is tracking Alzheimer patients at care facilities. So it's a very wide-ranging capability, and Sigfox is focused on that low cost, low power, long range capability.
All right, Michael, thank you very much. That was excellent. At this time, we're going to jump into our case study discussion, and Craig is going to start us off with an overview of case study sectors.
Yeah, thanks, Martha. I'll just be a minute here. The earlier slide I showed kind of talked about how you can segment IoT applications more or less kind of by performance or throughput characteristics. There's another way to look at it too. There's a lot of ways to look at IoT segmentation, but one way is kind of, we've started to think about IoT, and I think Michael just kind of hinted at it a little bit, is kind of what we see as sort of traditional M2M, as on the one hand, on the left here, these are long established use cases for connecting things to the networks, whether it's in security or retail or health or smart meters, fleet tracking, some of the stuff that Mobeen referred to in his slides. These are, very well understood traditional applications, and they're moving to LTE in our minds largely because, well, one, the 2G networks are disappearing and that have long powered those applications, and the LTE technology, like I mentioned, is now providing the coverage, the longevity, the cost, the power attributes that make it work. And the last bullet here, kind of network economics are matching the business, making the business cases possible. By that I mean I think carriers are getting more clever about pricing their service, pricing their access, and the other attributes there. So some of the business cases, even though a lot of people believe LTE is quote unquote the expensive technology, I think taken all together, between the cost of the hardware, cost of service, and the business case, the ROIs are making sense for these kind of traditional applications. And then on the right, there's sort of what we call emerging use cases. And Michael referred to some of these sort of things that have never been connected before, constitute a lot of this. It's a lot of sensors, tank monitors, smart agriculture, cold chain storage management is an interesting one. Smart cities, and then he mentioned also trackers. I think we've been tracking vehicles for a long time, and now we're going to track assets of all types, as well as pets and luggage and you name it. Tracking as these costs and battery life capabilities improve, and as the networks serve these technologies, I think you're going to see these use cases. And our belief is the cases on the right are going to dwarf the cases on the left in terms of volume over time. So it's going to be an interesting next, several years. Both of these are moving rapidly to LTE technology, Cat-M and narrowband IoT both, because of all of the attributes I've mentioned.
Okay, great. Thank you very much, Craig. Our first case study is from Mobeen, Grind to Energy. Mobeen?
Thank you. Yes. So Grind to Energy is a business within a very large company called Emerson. They have these large tanks that they are doing sort of composting and taking food into recycling food, if you will. So as we all know, a lot of food, especially from restaurants and bakeries and large grocery stores, goes to waste, and this sort of has both an IoT and a sustainability use case. So that's the problem that Emerson Grind to Energy wanted to solve, and wanted to connect a lot of their recycling tanks to it. So they came to us. I talked about our foundry, which is our sort of innovation center. We sort of whiteboarded the solution and all of the things that they needed, what kind of sensor data that they needed to collect and manage their operations, what kind, where were these tanks located, what kind of connectivity need did they have. So we took a lot of that into account, and then we started to put together a solution that included obviously the connectivity, but also some of the platform capabilities that we were providing. We ran a sort of a test system or a POC system with them early last year, which then was taken into a field trial and then finally launched with their production systems. And we added quite a few other capabilities, because it was not just about collecting the sensor data at the end of the day, which was good, but what we started to see was that if we collected enough of that data from enough of these sites, we could start to get some better visibility into their operations. It can optimize those, especially maintenance schedules, but eventually may be able to do some predictive modeling on when they needed to do these kind of maintenance cycles to prevent these tanks from failing. So how it works, so Grind to Energy, they have these large tanks. There's a picture coming up which will show you, install these large tanks into the customers where this food waste is processed, and it turns it into liquid. We connected those tanks, large tanks, with our global SIM and LTE network. We also connected it through our platforms so that we could collect, organize, and deliver the data. And that data shows up in some sort of a dashboard for Emerson customers, and so that they are better equipped with getting visibility into their environment. So let's go to the next slide. So obviously the biggest benefit they're getting is uptime. That's really what it's all about. If they can predict maintenance or figure out, predict failures and figure out maintenance schedules ahead of time, that is the biggest value that the solution provides them. And then on top of that, there are sensors that tell you about issues with the system that either on-site folks or dispatch folks from Emerson Grind to Energy can go take care of any problems if and when they occur. The last slide is, well, it's not the last slide. One of the major things that we showcased in this solution was the use of a repeatable capability of a platform. So what that means is that Emerson is a very large company, and they are using the platforms where we're collecting data from a specific set of devices that connect to this large tank. But a lot of that is reusable in the sense that they can change out the device very quickly and be able to collect that data. They're able to add things to the dashboard. They are able to add more sensors. They're able to collect more data without having to go rebuild a lot of the solution pieces. The architecture is all, the architecture of the solution based on this Flow and M2X platform allows them to be flexible and evolve this over a period of time. And then they can expand this to other verticals. And Emerson is a very large company. They support many, many use cases. And standardizing on a platform like this allows them to scale this to other kinds of data monitoring or machine monitoring kind of solutions. Next slide, please. So this is sort of a picture of what this tank looks like. There are many different sensors deployed along with that tank. It's usually in an in-building kind of an environment. Earlier, we were talking about LTE-M. Today, this is not an LTE-M solution, but this is the kind of solution that lends itself very well to an LTE-M kind of a solution where we can deploy things deep in the ground and at a very low cost for the customer. The other thing that's also important is it's a two-way solution. So typically you're reading data, but think about if you needed to update the device or update the machinery, you could use the same solution to go both directions, put data in both directions. So that's sort of the summary of the solution. And this is a view of the dashboard of the solution. You know, just like looks like any other dashboard. You can click into the data, and all of the data is available inside of the platform. So that's all I had in terms of sort of describing the use case, and happy to take questions later on or through the chat.
Fantastic. Thank you very much. And our next use case also involves AT&T, I think, water metering with Capstone metering. James?
Yeah, so recently AT&T announced that Capstone was launching a water metering as a service. I think it's, you know, if oil is the new gold, we got to look at water as the new oil, right? Water is the most valuable thing out there. Why are they launching water metering as a service? Well, it's because the EPA estimates 26% of water purchased by a water authority. It's either a city or a municipal water district. Whether it's purchased, pumped from a well, or diverted, collected and desalinated, whatever. It's lost prior to making it to the tap. 26% lost before it goes to the tap. The Energy Administration estimates 13% of electricity production in the U.S. goes to water, to pump it, to purify it, to heat it. You know, that's 521 million megawatt hours. Stated another way, that's 290 million metric tons of CO2 emissions, you know, from water. So water as a service moves the small and medium water districts from a CapEx to OpEx model. Now they have troubles today. They have troubles in managing employees, on employee turnover, on keeping long tenured employees in place. We're not talking about places such as LA or Dallas. We're talking in small and rural areas, most of these. There are 148,000 water authorities across the United States. They serve 98 million service connections. And about a third of those are in what we would consider the top tier, top 20 or 30 cities. The next are in, the next third are in medium-sized cities, and then it's split across small cities. And these guys are going to basically contact Capstone or AT&T. Capstone's going to provide the meter installation, the management platform, training, analytics, maintenance, connectivity from AT&T, and a cloud database. I believe they're going to be using MDX plus Flow Designer to be able to tie in that data, same thing that Mobeen was talking about earlier, and it's going to be cared for. All the district has to do now is receive the training from Capstone and AT&T, and they've got a full IoT smart meter solution in place. And this is charged per meter per month. Why would they want to go to an OpEx model versus CapEx? Well, the average truck roll to establish or terminate service runs between $40 and $100. In those smaller areas, those more rural areas, it can even range higher than $100 for a truck roll. The amount of time spent in a call center, getting service established, juggling your schedule to establish or disconnect service. This provides the stroke of a keyboard. Your water is on at the house or could be cut off. But the next thing it could do is that water district could use a white labeled application, provide it to their customer, the resident, who can then determine, oh, do I have unnecessary flow at my house while I'm on vacation? From that app, they could actually disconnect and shut off the water so they could have a leak. Because we have to think about this. The number one cost for insurance companies is water damage. And this makes things greener, safer, less costly for all those involved. It's really, really a neat solution.
Definitely. All right. Thank you very much, James. Next up, we're going to hear from Michael at Sigfox. Michael, can you hear me?
Yep. Thank you. Appreciate it. So I wanted to talk about one specific use case for Sigfox. We're tracking oxygen cylinders for one large Texas hospital for our customer, Airgas and Alizant. That's a part of the Air Liquide group. There are 11,000 cylinders in this particular complex, hospital complex in Texas. The first use case is simply to determine if that canister is at that hospital or not for billing and inventory management. It sounds pretty simple, but it's been a manual process for a long time, and it's pretty hard to keep track of 11,000 canisters at one hospital. So the first use case is simply to see if it's there or not for billing purposes and then inventory management purposes. The second use case follows that up by determining whether or not it's full or empty, or how full or empty it is, and does it need to be refilled? Is it time to pick up that bottle at that location to optimize deployment? And then from there, there's a number of different use cases that can expand from there. But those are indeed the basic ones, to try to optimize the process and to improve the billing that's able to occur right now. So to bring in more revenue for our clients directly. And then we'll get to better and more involved use cases over the course of time. The solution, as I talked earlier, is a multi-protocol cylinder head that has GPS, Wi-Fi, BLE, and Sigfox in it. That's built by Zergo. So there's a how full sensor in there as well that measures how much gas there is in the particular sensor. So Bluetooth is used for a local smartphone interface. So if you want to walk up to that particular bottle and determine what's in it right now, you can do that. Wi-Fi is used for location in the building. GPS is used for location outside the building. You can imagine these canisters travel over wide areas. Sometimes they're in a truck, sometimes the truck's covered, sometimes the truck's not covered, sometimes they're in a warehouse, sometimes they're being pushed around the hospital complex. So they move around a lot, not that frequently, but they move around a lot. And then Sigfox provides the long-range communication everywhere for that particular canister. So we're currently running a 300-unit trial at this hospital, and we are evolving to further use cases to manage the loss and the customer fees better over the course of time. Due to cost, where it's likely to end up at is that some of these will be Sigfox only, and we use the Sigfox native location capability for that. And then some of them will be included with GPS and with Bluetooth for other use cases, such as tracking stuff individually through a smartphone, where you can walk up to it and see what's in that particular canister.
Michael, thank you. Can you help us understand? I'm sorry, did you have more?
No, go ahead.
Okay, how does the hospital then get the data? Does Sigfox facilitate the delivery of the data to the hospital's database or cloud network?
So for right now, Sigfox operates on a cloud-to-cloud architecture. But the customer in this case would be the Airgas folks who sell that then as a service to the hospital. So
Okay.
it enables Airgas to improve their management of those canisters and then to bill the hospital accordingly. In a manual mode, it's very hard to tell where those canisters are and how many of those they should be billing for at any one time. When they can automate the whole process, then they can make their billing to the customer, the hospital, much more efficient. But to answer your question directly, our end customer on that would be Airgas Healthcare.
Right. Okay, great. All right, anything else on this case study?
Nope, all set. Thank you.
Okay, thank you. All right, and our final case study is from James with Otis Elevator. James, can you hear us? You may be on mute.
I was on mute. Sorry about that.
It happens a
So
lot.
I looked at additional case studies that service providers are doing to help their customers, I guess, transform themselves from being stodgy old companies to IoT-enabled companies. And two of the largest elevator companies, ThyssenKrupp and Otis, have selected partners. Otis was announced earlier or late last year, is working with AT&T. ThyssenKrupp's working with another carrier, but they're both doing something very similar, and they're actually connecting the elevator to look at the metrics to avoid downtime. So it's really interesting how much downtime there is out there from an elevator. But with over 2 million elevators from Otis and 1.1 million elevators from ThyssenKrupp, we're looking at for an average office building that's got 6 or more elevators, one of those elevators is out over 50% of the time. Well, when you're providing sensors in the elevator that could measure things such as vibration or if there's too much weight in the elevator on a regular basis, if there's some vibration going on, something like that, they can actually send it and dispatch a technician more rapidly. As in my previous case study, cost of a truck roll is very expensive. Cost of a truck roll is also very expensive for these guys. If I'm at one building and working on one elevator, I can check in and see how are the other elevators doing. Is there preventative maintenance that I need to take a look at? Are the things that we need to do today to harness this? When I've talked to other people about, elevators being big business, they say, well, there's not that many of them. Well, in the United States, around the world, and you look outside the U.S., we're seeing this trend of massive mega urbanization. In the U.S., we have about 1 to 1.1 million elevators in the U.S. operationally, and if you add in escalators and inclinators, we're probably looking at close to 2 million. In aggregate, 500,000 new elevators are being put on each year in China. The need to, when we're talking about building these massive 2,000 foot or 1,500 foot buildings, we need to actually really take a look at those and develop new generations of elevators that measure body temperature, things like that, that can turn on the air conditioning or heat when necessary, that better connect the people. They can connect to and detect smartphones, things like that, and know proximity. And the elevator companies will develop new responsive service solutions, providing more autonomy, more control over their equipment in their buildings, and actually go from being an elevator installer and manufacturer, right? And that building lasts for 100 years. You did it once and you just come back and fix it, to actually being a full-fledged, full-service company for the property managers.
That's great. Do you see this ever integrating with other smart building applications, HVAC or any other connected things?
Absolutely. I complete integration of that. to the different HVAC is just one, but lighting, smart lighting is going to be key. When the elevator nearly arrives to the floor, lights can come on in that floor, right? I mean, these things are going to be tied together. Absolutely.
Okay. All right. Great. Thank you very much. Oh, I want to take a minute to look at some of the questions that we're getting in from the audience. There was a question about Verizon case studies. The Verizon case study is in the report that was mentioned earlier, and there's also a Verizon case study involving drone use that published today on the RCR Wireless website. We're also getting questions, Michael, for you about Sigfox. The first question I got about Sigfox is Sigfox a proprietary protocol?
Yes, I was just in the process of answering that question via text. So I'll go ahead and answer it here. Sigfox is active in the standards bodies and has the most open ecosystem in the low power WAN space today. But at this time, it is still a proprietary standard led by Sigfox. As standards in the LP WAN space mature, we'll be there. I mean, we have many silicon and module providers and partners out there now building chipsets for our system. And, things are out there right now and available for us. In that sense, we're the most open LP WAN system out there today. Some of the other folks are tied to particular chipsets or tied to particular ways of doing it where we're not. But to be, quite open about it, today it's a proprietary standard led by Sigfox, and we're participating in the standards bodies. And as things move forward, we'll be part of that activity.
Okay, great. Thank you very much. And we're also getting quite a few questions about security. So, Michael, you said that you work with several chipset vendors. Is the security layer part of what the chipset vendor deals with?
Sigfox has a multi-layered approach to security. I'm probably not the best person to talk to that. At the chip layer, we have 128-bit AES encryption there, and so the chip providers do provide that as part of putting our firmware stack on their chips. At the system level, that's out of my depth, but we have end-to-end security provided by the system. And I'm happy to provide the data for someone if they wanted to delve into that a little bit further, but I'm not the right guy to talk to that in detail.
Sure. Do any of the other panelists want to comment on security?
Yeah, this is Mobeen. Agree with the fact that security. The two things about security: one is it is a multi-layered approach, and secondly, it is relative. What that means is that you can make a set of solutions and end-to-end data secure for a specific customer, and then let's say you take that into another vertical like a hospital or banking or government, and you will have to provide some added layers of security. So from a multi-layered approach, you need to secure the network pieces, which I think most operators or providers do a very good job securing, but then it's the end devices, and that's where many of the vulnerabilities typically happen today, is to make sure that the device manufacturers, who are not directly controlled by any of the operators or solution providers, tend to build devices with their own architectures, and so and there is no security audit that you do on those devices. So I think that's where it's important to educate the device manufacturers, engage them at a solution level, make sure that the chipset to the modules to the devices that they build have the appropriate securities for the target use cases. And then on top of all of that, you want to make sure that whether your solution requires encryption, should it go through open internet, and should it use a VPN or a VPN connectivity so that it's never actually open, or is your device ever open? Is your subnet ever open to the internet? So a lot of those questions have to go through during design phases when you talk about security.
Okay, great. Thank you, Mobeen. And we have a couple of more questions for you. Someone has asked if there are any ROI numbers for the grind to energy case study, and someone else has asked if you could comment on the advantages of the AT&T IoT network compared to a mesh network for metering.
Oh, for metering, yeah, okay. Yeah, so let me address the first one. So ROI is, James talked about earlier, a truck roll. So one of the ROI is a truck roll. A truck roll costs about, depending on where and how, anywhere from a couple of $100 to $500. And so if I can optimize that truck roll, I save that money per trip. Secondly, for the actual end customer, this was an ROI from an Emerson perspective. But from an end customer perspective, it's really downtime, minimizing the downtime. If I can do maintenance ahead of time, and in downtime, typically in these kind of machines, it's not a downtime of a few minutes when a server goes down or a couple of hours. It can be downtime of a couple of days. And so it's the loss of revenue, whatever their revenue is for those couple of days, that's really the return on investment. On the metering side, there is architecture around mesh that you use, and we deploy that in many metering environments today using the LTE network to have a data collector. Let's say in a multi-story building, you can have a mesh per building and then an LTE connector from the building back to the network. And we've deployed several architectures like that. But I think with the LTE-M solution in the market, the device cost, the penetration, the battery life become quite advanced for the use case to become available for each individual meter to get connected. So right out of the assembly line, you can have a meter be just connected and on, as opposed to layering on another network layer like a mesh network or something else on top of the solution. So I think the LTE-M allows you to make that architectural change.
Okay, fantastic. Thank you. And we do have one more really good audience question that I'd like to introduce before we stop. I think perhaps the short answer to this one may be no, but there may be some comments on it. Someone says, is there any universal platform that connects the different solutions in the IoT domain so that things can communicate in a collaborative way for new use cases? So that is, I guess, $1 billion question. Does anybody have any perspective on when we might see something like that?
Sounds like a gateway to me. I mean, this is Craig. I think, there are, I know of companies who make multi-radio gateways that can handle PAN and LAN and WAN and, maybe a single backhaul to the internet or to the network. In that way that you can deploy multiple radio technologies in the devices or in the end nodes and sort of gateway them through a single link back to a cloud service or back to a network. I'm not sure if that's exactly what the gentleman or the audience was asking, but that's what comes to mind for me.
Yeah, Michael Orr here. I would answer that similarly, but a little bit different. A number of the large IoT platforms that are out there have the capability to integrate a number of different connectivity methodologies. And folks like Microsoft with Azure and AWS, et cetera, have a way to do that today on their platforms where all of the different kinds of connectivity have already been integrated, including Sigfox, including LTE, including others. And so from that standpoint, they would certainly be able to address different kinds of use cases that employ all these different kinds of technologies that we're talking about.
Okay. All right, great. Yeah. I'm sorry, go ahead.
And this is James. One other way to approach this is taking a look at what they're connecting, and it's going to be at that data layer. And we're so early into this thing, no one has created a universal data services exchange because there's so many different types of devices, so many different types of protocols, so many different communication methods to tie all those together. But right now, even early on in this thing, there are so many of them, as Michael said, that have the ability to connect the majority of things. So Amazon let's look at this as the 80-20 rule. Will we ever get to nirvana where 100% of things can connect to 100% of things? Maybe. I don't look for it. But can we get to a point where 80% of things can communicate with them? Yeah, I think we'll get there. It's going to be through another unified layer, kind of at that data layer. One concept around that's what AT&T has done with MDAX with Flow. In basically piping in Azure and IBM and Blue Jeans Network and Amazon and the different data hosts out there to be able to view that through a single and controlled through a single control panel.
Yeah, this is Mobeen. I'll answer it maybe slightly differently than James did. I think from a technical perspective, that is possible today. The data sharing piece, how do you police the data, the policies around the data, that's all possible through many platforms, including platforms AT&T offers. I think the question comes in is who owns the data and how much of that data are they willing to share with the third party. So, for example, we work very heavily with heavy equipment companies. Think of large tractors, agriculture machines, construction site machines. And, the manufacturers of those machines, the yellow, the green manufacturers, there's some data produced by their engines and their machines that they are willing to share with everybody, whether it's a dealer, it's the end customer, and they make it happen through a policy. And we enable it on our platforms. But then there's other data that's proprietary. There's some of their engine codes and fuel level usage and so on, and they're not willing to share it with anybody. And so that data is locked up. So I think that use case by use case, it really depends on what data is shareable and can be shared, even through APIs with a developer community in the future. But many times that data is highly proprietary to the business or the ecosystem, and they are very, they're not very open to sharing it unless it's a very trusted community.
All right, thank you very much. We are out of time, so I'd like to thank everyone for being here, starting with Mobeen Khan with AT&T. Mobeen, thanks very much for being on the webinar.
Thank you for the invite.
James Brehm, founder of James Brehm and Associates, thanks very much for your comments today.
Thanks, Martha.
Craig Miller, Vice President for Worldwide Marketing at Sequans. Craig, thanks a lot for being here.
Yeah, I enjoyed it. Thanks, Martha.
And Michael Orr from Sigfox, Vice President for Sales and Partners of North America. Thank you very much, Michael.
It was a pleasure being here today. Thank you for having me.
We do have several unanswered audience questions, and we'll try to get back to those one by one as best we can. Thank you all for being here today, and this will conclude the webinar.